All right, let's start.
All right, Craig, you're up, buddy. You sure you can hack the system?
I've hacked into the Pentagon, the Chinese currency exchange, and Obama's Skype account. I think I'll be fine.
Fine. Enough talk. Get to work. So this guy's good, huh?
Yeah, he's the best. Why?
It's just, he's not even typing yet. Shouldn't you be typing? Like super fast?
Listen, don't worry. He's got this.
Are you sure?
All right, look, it's been 2 minutes. Okay, hold on.
ETA, buddy? How we doing? Because those guards are gonna be on our asses any second.
Yeah, I'll just tell the computer to load faster. So.
But could you though with hacking? Craig, those guards, they're almost...
Okay, so stop the guards with bullets.
Can do.
I will, but there's a reasonable limit.
How about you let me decide what a reasonable time limit is for hacking into a high-level security system?
All I'm asking for is an ETA. A minute? What?
I knew you'd be one of those people. You think hacking is so easy? Like I just hit some keystrokes and the clicky thing and then boom, hacked?
How long, Craig?
All the time in the world! Like, could be. Ow! Hacking is pretty complicated. It's a lot of guessing shit. So.
Get into the security system, lock the door, and buy us some time.
If only, right?
Yeah. Wait, what? No, do it!
Oh, okay. So I'll hack into the head of security's gun, and then the hacked gun will shoot the guy. Right?
So you can't get into the security system.
This isn't hackers. I'm not Swordfish.
Swordfish wasn't even a character!
Security systems aren't like a place I can find and hack into.
Just please, as fast as you can.
It's a little hard with all this stress around me.
Stress?
So...
Just imagine you have all the time in the world. Imagine you... Hack the alarm off!
What did I just say about hacking?
A lot of f***ing things!
I can only hack one thing at a time!
You're not hacking anything!
I'm sorry, Joe. I was wrong. Craig sucks.
It's okay, Mike. At least we'll go down together.
Any questions so far? There's I find it funny when you look at the perceptions people have, right? Like what they think it is like versus the reality. And yeah, part of what I want to try and do in this talk today is separate a little bit of that. And I thought what we should do is look at the way a whole bunch of stuff is changing into the future. Like there's a whole bunch of really, really cool security stuff we've got now that when I talk to people about it, they're like, oh, I never knew this thing was there. And they're super cool, and a lot of them are really free and easily accessible as well. And I want to talk about those. I want to show you what they look like, but also want to sort of set a little bit of context as to where we're coming from and how low the bar often is for security. And I found a really good Australian example that came up last year, and it's kind of a little bit of an embarrassment as an Australian to show this, but we have a bank. It's Commonwealth Bank. And it's the biggest bank in Australia, like tens of billions of dollars that they make every year. And recently, they were decommissioning a data center. So they wanted to shut down a data center in one location and just move everything over to the other location. And during this process, it eventuated that they lost some data. And I've got a little bit of video that explains what happened in order to lose the data. And it turns out that what they did is they shut down the one data center, they put all of the data from that data center on a truck to take it to a secure destruction facility. And I've got some file footage of the truck. And this is a truck with all the Commonwealth Bank data on it. And the idea is that you put all like the tapes and the hard disks and everything like that, and you drive to a secure destruction facility, and they got like those big disk shredders, and you'd put them all in there and all of our data would be destroyed and it would be fine. Anyway, the truck's driving along and it's turned out that they actually put a little bit too much data on the truck and they lost some. And this is actually, okay, other than the video, this is a true story. So they had to get KPMG in to investigate what happened. And KPMG said they retraced the route of the truck to determine where they could locate the drives along the route, but were unable to find any trace of them. And this is real, like this is how we're having data breaches still. This is like IRL equivalent of an open S3 bucket or something. You know, just chucking all the data out there and people get it. So we've got a really, really sort of low bar, you know, like a low baseline to come from. One of the things that I'm doing a lot of is spending time reporting data breaches to people. So I have someone pop up on the internet and they say, here's some data, it's allegedly from this site, maybe you want it for have I been pwned? And I've got to do the right thing, and I've got to try and get in touch with the company and say, look, someone has sent me data, I think it's your data, you probably need to do something about this. So someone sent me some data recently from this site. Now, this is adult fan fiction, and I'm just trying to think about the best way to explain what these guys do. Probably start with the advertisement, which will give you a little bit of a sense of what sort of site this is. Just realised my 9-year-old son's here and I've got to explain this somehow. When one vampire really loves another vampire, and someone wants to write a story about it, and this is what it is. It's like erotic fiction for fictional characters, right? You know, like fair enough, some people are into that, well, whatever, I don't mind too much. Someone sent me the data and I've verified it. And I verify data via a number of different ways. So things like, I'll look at the data breach and I'll go, oh, there's a bunch of mailinator addresses in there. So mailinator addresses are throwaway email addresses, right? People don't expect to have privacy. In fact, they're open mailboxes. So I'll grab a few random mailinator addresses, I'll go to the password reset page, and I'll see if there's an enumeration vector. Can I put in a mailinator address? Does it come back and tell me that it exists? Or does it say it doesn't exist? And even if it's neutral, if it's like, maybe it exists, maybe it doesn't, it's an open mailbox, so I can see if it actually receives a password reset. So I verified this data and went, okay, it's legitimate. I'm going to have an uncomfortable discussion with these guys. So I sent them an email. And often I'll send emails like this when I'm reporting a data breach. And I don't want it to look like a scam, right? And I don't want it to look like a shakedown, like I'm just after money. So I sort of say, hey, this is me, this is the site I run, here's a proof, right? So 3 lines from the data, usernames and the hash of the password. And if you think about it, right, like if a system administrator gets this and they're like trying to figure out whether I'm legitimate or not, and they go, oh, there's 3 hashes in there, I'll just see if those hashes exist in our system. If they do, it's almost certainly going to be legit. So I sent this out, this was 19th of July. Sent it off to them and thought, okay, good deed done. They'll get this, and then they'll get back to me, and then we'll fix whatever flaw it was that exposed the data, and you know, everyone can kind of move on. So nothing came back. Nobody replied to me. And eventually I just went, okay, it had been like more than 2 weeks. I went and tweeted it. I loaded the data. So this is the 6th of August. In fact, that's probably going on about 3 weeks. Flagged as sensitive, so sensitive data breach and have I been pwned, you can't search for someone there publicly because it could cause them embarrassment. And a site like that, yeah, it could be a bit embarrassing, right? So you see it's got dates of birth in there as well, that's pretty personal data. Interestingly, passwords stored as both MD5 and plain text. I wonder if this was so that they could like easily upgrade the hashing algorithm later on. They're like, well, plain text passwords are there. So I loaded all this in. It's a pretty small data breach as far as data breaches go, 186,000 records. So anyway, it's all gone in. And then shortly afterwards, someone posted to their forum. And they said, hey, I got an email from Have I Been Pwned? And then down the bottom they said, is it true and why hasn't it been addressed? Is the site still vulnerable? So think about what's happening here. Here is someone who uses the site and has got an email saying, your record was in a breach from the site. It's probably legitimate, unless I'm like randomly guessing members of a pretty niche website. Someone else chimes in. They said, I got the notice too. So now we're sort of getting reinforcement, right, of the original message. And multiple people saying, I got this message, I'm a member of this site. And then it sort of started to go downhill because Demon Goddess joined the chat. Now, Demon Goddess is a head evil tech wench. And she is a site administrator. And she wasn't very happy about this. No, it's not true. One would think that instead of scaring users, these companies would contact the site itself. I tried. That email actually went to 2 different addresses, which they'd published on the website. So you're probably beginning to see the frustration. It's like, I tried to do the right thing. You didn't reply. Now, eventually, it's gone public, and now you're pissed that I didn't do what I actually did, but you just didn't reply. So anyway, then she's decided, maybe I should reply. So she sent me an email. Said, none of this data exists in my database. Well, yes, it does. Sorry for late response. Been working hellacious hours at my day job. Demon Goddess 61. I sort of had this bit like, what does Demon Goddess do in a day job? Maybe she's a lawyer in a nice suit. I don't know. This could just be a moonlighting thing. Anyway, she sent me another one a few minutes later. Now that I've verified this doesn't exist in my database, I expect you to remove the site from your data breach website. Now, please. Nope. I'm not down to do that. And we had a bit of backwards and forwards, and I was explaining to her what happened. Because I get it, right? Someone's running a site, running a forum. They don't know this world of data breaches. It's a bit of a weird thing. But we go back to the thread, and someone else chimed in. Bronx Wench. Now, Bronx Wench is a mighty dragon wench. I'm not making this up either. Like, it's all out there. Trust me. And what I thought was interesting here is she says there's no gain in hacking us. We're not an e-commerce site. And I say this all the time, right? Like, websites go, there's no e-commerce data, no credit cards, no banking. Like, what's the point? Well, the point is you're there. Like, that is the point. You're there, you're online. Plus, you also have 186,000 members with plain text passwords, and you know that they're going to unlock accounts in all sorts of other places. Apparently, I'm looking to terrify people into buying security software. I'm not quite sure how that works, but anyway, we move on. She says he sells private workshops and courses. During those, you'll be offered the opportunity to purchase security packages to prevent data breaches from impacting you. How many people who came to my workshop actually bought a security package from me? No, shut up. I was just going to say, like, I'm a really bad salesman. I'm happy to sell you a security package, Scott. So, obviously a little bit liberal with the truth. And she says, perhaps we don't have high-priced lawyers who'll take him to court. Perhaps he thinks our members won't report him for publishing their data without permission. That's what I intend to do. And this is back, where were we? Back in August. I'm still here, like nothing has happened yet. But it's this reaction from people who find out about this. But the core thing that I want to get to here, and you'll see why in a moment, is that I couldn't get in touch with this company and report it and deal with this silently. Like, this is not a discussion anyone should be having publicly. It's a discussion we should be having privately around what actually happened. Is the data legit? What are we going to do about it? And to be clear, like, I don't shake anyone down for money or anything. It's like, look, here's your data. If you want, here's some blog posts I've written that will give you some advice about how to communicate what happened. But if someone won't reply to me, where do we even begin? We see this over and over again. I'll give you another good example. So this is Luas in Ireland. This is Dublin's light rail system. This is what the website normally looks like. This is what it looked like earlier this month. You are hacked. Like, this is literally what the website said. This is their entire website, by the way. You are hacked. Some time ago, I wrote that you have serious security holes. You didn't reply. The next time someone talks to you, press the reply button. And you see this like over and over again. I am trying to tell you something. Now, admittedly, this is not the right way to tell people something. It's just like, I can't get in touch with you, just nuke your website. And then this guy sort of made it worse as well, because he said, all right, now you've got to give me a Bitcoin. Otherwise, I'll publish the data. As far as I know, that hasn't happened. I haven't seen the data published. I haven't looked at that Bitcoin address either, but I don't think Luas is going to pay any money. So they got this message. This is what their website looked like in the first week of this month. This is what it looked like shortly after. There's a tweet. They said, hey, it's compromised. Luas are informed this may take the day to resolve. The day. This is a week later. This is another week later. And if you look at it today, it looks like that previous one. So they still haven't got the site back online, and we're what? Getting towards the end of Jan. And it's sort of the same thing over and over again where someone is trying to communicate and they just can't get through. Now let's talk about solutions to this, because there's actually a super cool way of making it easy for people to communicate security vulnerabilities to you. And it's this. Has anyone used a security.txt file before? All right, so this is interesting that it's like 3 people out of the entire room. Now, security.txt file is a proposed standard which allows websites to define security policies. And what you do is you put a text file on your website like this. That's all it is, a text file in .well-known, and you call it security.txt. And if you want to have a look at what it looks like that. So that's have I been pwned. So if anyone finds a vulnerability, or if they think there's a data breach or something like that, it's super easy to get in touch with me. And because this is a proposed standard, we see the same pattern being used over and over and over again by many different organizations. I'm going to show you some of those others in a moment. Firstly, this proposed standard is made by this guy, Ed Overflow, not his real photo. So, yeah, Ed's a smart guy, and he's come up with something which is just really basic and simple to use. This is Google. So Google have contact information. They publish their public key. They've got acknowledgements, policy, hiring. You can put comments and stuff like that. They've got a BountyCon reference in there as well. Dropbox has got one. Same sort of stuff. Contacts, acknowledgement, policy, hiring. Would you like a job? Maybe in a security capacity. BBC's got a really big one. I don't know why the BBC go on so much. They've got a lot of comments in there. But this is great, right? Like, this is a really simple thing to do. This is security that doesn't cost you money beyond writing a text file. The biggest expense in this is going to be talking to your company lawyer and convincing them it's a good idea to publish information about how to be contacted if there's a breach, because lawyers are a bit funny about all that sort of stuff. Now, there's a heap of different websites around the world that are now implementing these. And you can have a look at Scott Helm's crawler. So he goes through and indexes the top 1 million websites every night. And one of the things he indexes is whether they've got a security.txt file. He indexes a bunch of other stuff as well, but this one's kind of cool because you can go and see how rapidly the adoption rate of this is expanding. This fundamentally changes the communication process when there's a data breach. Now, unfortunately, I've never actually found one on a site that's been breached, and I wonder if part of that is that sites that are conscious enough to actually do this generally have a higher level of security as well. So do this, do me a favor, go and get this in your organization, because this is a super cool thing. All right, so something else that's been very prominent recently is these guys. Anyone know who MageCard is? Ooh, this 1.5, maybe. So MageCard is interesting. It's a group or a collection of groups that have been very good at stealing credit card data from websites. And they've been in the news a lot lately because of events like this. So British Airways last year, and the headlines are always around credit cards being stolen. And then when you read the details of the stories, it's not just like primary account number, it's stuff like CVV as well. And everyone loses their mind. They're like, British Airways is storing CVVs in the database in clear text, now they've all been stolen. That's not what happens. You're going to see what happens in a moment. Ticketmaster. Ticketmaster was a big one too. And these guys, OXO. So earlier this year, OXO was on the list as well. And OXO does sort of kitchen supplies and things like this. Big in the US. All of these companies had credit card breaches due to MageCart. And I want to show you what it actually looks like in terms of how these breaches worked. OXO, we know exactly how it worked because archive.org indexed the site whilst it had been maliciously modified by MageCart. This is all it took. So it's one line of JavaScript. But what can you do with JavaScript? I kept asking this in my workshops, like, what can you do if you can run any JavaScript you want on someone else's site? Basically anything. So what's been happening is MageCart has been getting a line of JavaScript on a compromised system. Now, if they can get that line of JavaScript on the compromised system, their script can run in the context of every single person's browser on that website. So how do they get the JavaScript there? compromised CMSs, good example. How many CMSs are out there sitting behind websites that allow you to add things like script tags? Because marketing needs to. Don't let marketing add script tags to your website. Other compromises: weak admin credentials, getting you into the CMS, weak credentials, getting you into FTP, whatever it may be. There's a lot of different ways you can get one line of JavaScript on a website. Persistent cross-site scripting, one line of JavaScript. The file behind this JavaScript looks like this. We're not going to read all of this, but the thing to note here is pretty much sort of the first half of the screen references a whole bunch of fields. There's like this array of fields. And what it's actually doing is it's registering listeners on different fields to say when this field changes, send a request. And what I want to do is sort of mock this up to show you how it works and then talk about some really super easy defenses. So I built a mock-up OXO website, which is this one. I've got a host entry on my local machine so that oxo.com just goes to a local version of IIS that I'm running. And this is a checkout page. Looks pretty normal. But here's where it gets interesting. If I jump into the Dev Tools, go to our Network tab, and I go and start filling out credit card data, and I go to the next field, it's a request. Change the month. Another request. The year. Another request. Enter the CVV. Yet another request. And what's happening is there's this little listener on every one of these fields. And on the onChange event, it goes through and makes a request to evilcyberhacker.com, which is my website. Incidentally, MageCart doesn't normally send requests to like Evil Cyberhacker or MageCart.creditcardtheft.com. Like it's usually to something else. There's a token here, so this token is generated so that it's unique for this browser session. And what it means is it's going to tie each one of those individual requests together. It's going to be the same token for each request. Here's the host. That's what's up there. Here's the name of the field, which has just been changed, and then here's the value. And that's it. Like, this is just super, super simple stuff. Every time the field changes, send a request with the data that was entered into the field. This is not hard. So what are we going to do about it? Well, the first thing is obviously don't let evil cyber hackers put lines of JavaScript on your website. You know, like compromised CMSs and things. Not a good thing. There are other ways this happens, and I'll talk about those in a moment. But one of the things that's really, really effective against this is a content security policy. Who here has written a CSP before? All right, like everyone in my workshop, and then a few other random people. So content security policies are super cool because what they allow you to do is define a policy that specifies where the website can load different things from. This is identical to the previous tab, identical page. The markup's identical. The only difference is that there's a response header here. If I pop this open and I reload this page, it's going to load it back up from my local IIS. Bam, first request, down to here. Here's my content security policy. Now, the main thing to remember here is that a content security policy is just text. It's just a response header. This is all it is. And the policy then declares where you can load stuff from. I made this one super simple, and I basically said, look, you can load stuff from this own website, from self. Most CSPs end up saying, I can load scripts from Cloudflare CDN. I can load styles from this other location. I can post forms to this other location. And it declares everything that your site is allowed to do. And if anyone tries to do something that's not explicitly declared, stuff breaks. Now what that means is that if I go and kill that, and I go down here and I actually try and change these fields again, nothing. Nothing is happening. And if I look at the console, it tells us, refuse to load the script from evilcyberhacker.com because it violates the following content security policy. So the script is still here in the page. If I jump into the source code of the page and I look for evil cyber, it's still down there, right down the bottom. But it won't run, it's been blocked by the policy. See how simple that is? Like, that is just such a simple constraint. And when we're sort of talking about hacking to the future, this is the direction we're trying to go. There's only about 3% of the world's top 1 million websites that have a CSP. And it stops stuff like that dead. It gets cooler though, because if someone's trying to mage cart you, you kind of want to know about it, right? I would like to know that someone has been able to put arbitrary script on my site. So we go on to the next demo. Page looks the same as it did before. If I pop open the DevTools, still got the same console error here. Network tab, let's reload this page. Go up and look at the first request, look at the response. This is almost the same CSP as before. The only thing that's different is this bit. And this bit says, if this content security policy is violated, I would like you to send a report to this URL. And you can send reports to anywhere you like. They're just JSON requests. I'm going to show you what it looks like in a moment. I'm sending it to the service that Scott Helm and I run, report-uri.com, where we receive billions and billions of reports of this sort of thing. You can build your own reporting endpoint, send it to there. Main thing is that what this construct lets you do is not only block the attack, but get your users' browsers to tell you. So you're turning your users' browsers into like little beacons all the way around the world. And if anything goes wrong, they're all sort of pinging you with reports. So if we now go and look at the responses here, we'll scroll down a bit. Find the right one. First of all, blocked CSP. So magecart.js wouldn't load. Second of all, straight after that, there's a report that's going to the report URI, which I declared earlier on. And if we now drill down into this report, we can see that it was a post request responded with 201 created. And if I go down into the request body, here's the JSON of the request. And this is cool because imagine that you started receiving this from your users visiting your website. It would say, hey, we blocked this URI, and you'd look at this URI and go, oh, this isn't good. You know, like that shouldn't be in there. And then it tells you, what's the document URI? So this is what you see in the address bar at the moment. So you get told which page on my website was trying to request which resource from somewhere else. And then you can go and figure out how the hell that actually got onto your site. So content security policies are really, really powerful that way. And again, like they're free. This is not something where you go and give a vendor like piles and piles of money. Now I mentioned the ways this happens is we have things like compromised content management systems, compromised credentials, something which is a security flaw with the website that's being ultimately having their credit cards sucked out of them. It doesn't have to be a problem with your site though, because what if your site has dependencies on somewhere else? How many websites today load script from other locations? My website does. I have Discuss on my blog. Have I Been Pwned does. It loads jQuery from Cloudflare CDN. Ticketmaster loaded this. This is Inventor, and Inventor do chatbots. So Ticketmaster wanted to have a chatbot on their website. So they embedded Inventor. They would have had a script tag that would have pulled down the Inventor script and run it on their site. Ticketmaster didn't get mage carded, not directly. These guys did. So what happens if one of the third parties that you're dependent on has a compromise? Because now your sort of ecosystem of dependencies is this great big spider web of things all the way around the world. And your security posture is determined by what happens to every single one of those. The thing is, though, the content security policy still applies. So your CSP, if you're using a service like Inventor, would say, we're allowed to load scripts from Inventor. And that's fine. And then if Inventor then tries to go and load scripts from evilcyberhacker.com, it gets blocked because you've not whitelisted it. So I love this because CSPs are just such a simple, simple thing. And they're free. Okay, so that's MageCart, CSPs, and compromised JavaScript. I want to talk about something else, and this sort of brings us back to Oslo a few years ago. I was doing a workshop here. It would have been 2016. And the same workshop many of you are in yesterday. And yesterday we did this exercise where you take your mobile device and you proxy it through your PC. And it's kind of interesting, dead easy to do. If you weren't in the workshop, all you got to do is get Fiddler. So you get Fiddler or Charles Proxy if you're on a Mac. You set the proxy of your device to point to your PC, and then all the traffic starts flowing through your PC, and you can see all the network requests going. And you learn super cool, interesting stuff. So I did this, this workshop with the NDC folks, and there was a guy in my workshop that got very, very excited by it. He thought, oh, this is a lot of fun. I like this. So he went back to his hotel room at the end of the day, and he's like, I'm going to proxy my device and have a look at a whole bunch of different applications and what they do. And it turns out he has one of these. This is a Nissan Leaf. And what I subsequently learned is that the Nissan Leaf has a companion app. This is what the app looks like. And what you can do with the app is pull back the battery status. You can turn on the heater. See, I didn't know this because in Australia, we're not worried about turning on the heater. Australia, we have a different problem. Now, this is a true story. If you get into a car in Australia too quickly, this happens. This is real. This was just the other day. It was in the news. It's like this guy left his car in the sun. He got in there, sat on the seatbelt. Now he has a tattoo. Different set of problems. So anyway, the guy's going, I'm curious to see how my app knows to talk to my car. Because there's lots of apps and there's lots of cars. How do we get the right apps to the right cars? And the question I was really asking is there like some sort of bearer token model or something? You know, like do I get this token and then this token is a secure, cryptographically signed, tamper-proof token that only connects me to my car and everything's okay? And in effect, what he was trying to do is find the API key of his car. What he learned is that the API key for the application is printed in the windscreen of every car. So the VIN number, the vehicle identification number, is what's used as a key. And you could walk past cars and go, that's my car, because now you've got the API key. So you could then go to the app and literally turn things on in the car. Now, thank God you couldn't make the car steer or turn or do any of these things. It was just pulling back trip history and battery status and stuff, but it was turning on climate control. Like you are actually making things move in the car if you can see the API key printed in the windscreen. Now, it's kind of worse than that as well. And the reason it was kind of worse is that the last 5 digits of a VIN number are enumerable. So you can go and get a VIN number and then just start guessing cars. So when he came in the next day and we wanted to establish if this was legitimate or not, we took the URL that had the API key in it and we just kept randomizing values. And every now and then another car would pop up. So we looked at it and went, oh, this isn't very good. You know, like we're going to have to do something about this. So I got in touch with Nissan. And in fact, I tweeted. It's always funny when I tweet this. Hey, does anyone have a security contact at Nissan? And everyone's like, oh, shit. This isn't going to be good. So someone from Nissan got in touch with me. And we sort of had a bit of a chat online. And then we had a chat via the phone as well. Like they were taking it very, very seriously for a few days. And then they kind of got busy. And they had new cars to build or something like that. And the whole thing just got dropped. And they were no longer interested in dealing with it. And this is enormously frustrating because I'm sitting here going, but I can control bits of cars. Like, why would you not want to fix this? So I kept following up. And then they stopped replying to my emails. And it got to the point where we're now about a month in. And I'm searching around the internet because it's like, what am I going to do? Like, if I dump this publicly, this is going to be a really, really major thing. So searching around the internet, and I discover that someone else has found the same flaw. And the way this actually came about is there was a Nissan Leaf forum, and people were saying, the Nissan Leaf app is really shit, right? It's terrible. And what I want to do is I want to be laying in my bed comfortable while I'm turning on the heating. So what you do is you take this URL, you replace the VIN number with your own, and you add it to your browser as a favorite. Because it's just a GET request. Who's upset that you can actually change state with a GET request? Anyway, different story. But this was it, right? And you had like one favorite, make car hot, make car cold. And you'd sit there in bed, hitting favorites, turning the heater on or off. And I'm looking at the thread going, do you not understand what you've found? You know, like this is actually really bad. So I got to the point where I went, all right, I'm going to publish this, screw them. And I did actually email them and said, look, I'm going to publish something on this tomorrow. And around about that time, I discovered that Scott Helm actually had a Nissan Leaf And I was like, oh, this is really convenient. we can do something with this. So I had to work out what to do, because when you cover something like this, you want to have impact, right? You want to get airtime, you want to get it noticed, because clearly they're not paying any attention just to me. So I need to amplify the message. So I wanted to create something that people would see and they'd pay attention to. I also didn't want to over-sensationalize it. You're not about to go and start crashing Nissan Leafs with this. That's not what the risk is. So what we decided to do is make a video. And what we did is I went and sat by my pool, because I was back in Australia and it was warm. Scott's in England, so he looks miserable. And we did this little video. I'm going to play you the first part of the video here. So look, what we want to do then is see what I can control from this end. And I guess the first thing is I can see that you got a big jacket on. It's cold there. Should we look at what we might be able to do with the heater, see if we can bring you up to Australia temps for a little bit? Look how much happier he is when I talk about getting warm. So the URL to hit is this URL here. And as you can see, it is a GET request. Goes off to this funky looking domain, passes the VIN. Oh shit, that's your VIN. Okay, who can turn Scott's car? So Scott has subsequently sold the car. And just so you know, like, I didn't show this publicly until you'd sold the car. So yeah, Scott sold the car. I don't know why. But this was the request. And you'd make a request like this, and it would return a response like this. Now, of course, as part of the response, it's actually returning information about him, because the user ID is in there. So this is like a little bit of exfiltration. You can enumerate through the identifiers in the VIN number and start to pull back identifying information about the owner. So when you hit this request, it's going to make the car warm. So let's see what happens.
It's beeping. Oh, there we go. Oh, my heated seats have come on. Yep, the air conditioning and the fans have just come on as well. You can see there's a status indicator on the dashboard to show that the car's currently being controlled remotely, which is now blinking. And I'm not sure if you can hear that, but all of the fans have come on full power. It's actually quite loud in here.
And like that was it. That was the proof. So I published this, and then you wouldn't believe it. Suddenly it was important to Nissan. Because now there's news headlines all the way around the world. Car hacking. Which, of course, again, like, you're not driving the car, but still, of all the different connected things you own, the thing that you probably least expect to be remotely hacked is your freaking car. So it's interesting to sort of think about what it is in the design decisions by the developers that make something like this possible. And I'll tell you what I think it is. So let's imagine we have a happy Nissan Leaf owner here. It's our Nissan Leaf owner. Now, the Nissan Leaf owner is using the mobile app. And this is their entire exposure to the service. That app is then calling back into the API. And of course, the API is then calling back to the car. Now, just to be clear, it's not like your Nissan Leaf is running Apache, right? This is not how it works. There is a service somewhere which is addressable over the internet, receives these calls, and then it communicates via a back channel over a GSM network or something like that. So you're actually communicating, the app is communicating with a traditional web service somewhere. So here's where I think it always goes wrong. We've got this relationship here, right? We've got the user with the phone. And every time we do user acceptance testing, it's a user with the phone. Every time people are experiencing the app firsthand, it's the user with the phone. Like, this is the thing that they see. And the communication here gets overlooked. We miss this time and time again. Because an API it's not like a website, right, where you can see a URL and you can go, oh, there's a number in the URL. What happens if I change it? It's just that much further away. And what I find is that developers consistently make assumptions about the way the phone will talk to the API. Everyone knows what I say about assumptions, right?
Assumption is the mother of all fuck-ups.
Exactly. Now, we see this over and over and over and over again. So that's what caused the problem with the Nissan, assumptions. Now, it went offline for a long time. It did take them quite a while to fix this. I don't know why, but it took them a long time. It was down for weeks and weeks. And eventually they got the app back online, which was good. And Scott sent me a screen cap of the app. And he said, have a look at this app and see if you can see anything funny about it. See if the audience can spot it. Now, I know it's a little bit small for some people, so we'll zoom. Now, keep in mind, this is a consumer-facing application. Mums, dads, normal people driving around their Nissan Leaf, and we've got this app explanation about Stack Overflow. Why is this in here? Who wants to guess? Copy and paste. And you can actually find the original answer on Stack Overflow. And they copied and pasted this. They're building cars, and they copied and pasted code without reading it and without understanding what it does. And it's even worse than that, because what's the second word I've highlighted there? Spirit, right? What's the second word here? They typed it. Like, why would you retype this? I don't understand what would cause someone to want to do this. So the app was offline for a long time, and that actually made some people a little bit upset. And this guy posted a review of the app to the Google Play Store. And what he was actually upset about was me. So it feels like a very polite English insult, rather stupid. And I saw this and I thought, well, there's obviously only one thing I can do with this. I'm going to print it out and put it on my desk because I think it's kind of cool. There's a little reminder that people sort of need help saving themselves from themselves, because so often they just have no clue about this stuff. So that was Nissan, and that was quite an interesting experience, if I'm honest. So we keep seeing this sort of stuff happen over and over again. And it's just kind of interesting to see, even as we have newer defenses and smarter ways of dealing with stuff, we see a lot of the old stuff continuing to deliver vulnerabilities. And another good example of old stuff continuing to deliver vulnerabilities is cross-site scripting. And I want to show you a very short video and then show you a cool thing that we can do, not only to try and stop this, but to try and learn about it when it happens. This is a video created by a Dutch journalist called Brenno de Winter. And I showed this in my workshop a couple of days ago. It's only about 30 seconds. What this guy's done is he's found XSS vulnerabilities in Dutch banks. And he goes around exploiting these vulnerabilities entirely with JavaScript, and he gets the websites to do this.
Con los terroristas.
So all that music is being played by the cross-site scripting, and the shaking is the cross-site scripting.
And do the Harlem Shake.
Fun times. You don't really want your bank doing this. And incidentally, just for those of you that aren't familiar with XSS, this is not what people normally do with XSS vulnerabilities. They put keyloggers on there, or they exfiltrate cookies or something like that. You can see in the URL, just towards the end of it, there's an eval in there. So eval is often used to concatenate parts of an XSS payload together and then execute them. So in many ways, this is old news, same old stuff. But I thought I'd show you guys some cool stuff around what the browser does with XSS and ways that we can better protect websites and learn about when things like this happen. So I created a little website, and all it does is lets you search for beer, which seems pretty good. So you go on this website and you go, beer, bam. It comes back and says, you searched for beer. Cool website, yeah? All right, now, here's the thing. This is reflecting the untrusted user input. So I'm entering beer into the text box, and then beer is coming back out. You can see it's in the URL, and then it's reflected into the source code of the page. What if I search for a script alert beer like this? Because if I did that, and it just reflects that back into the source code, I'm going to copy it because we're going to use that a bit. You do that. Because I've now got a piece of JavaScript in the source code of the page, and the browser is just running it. It's alerting it back out. Now, you wouldn't normally be doing this any more than you'd be doing the Harlem Shake. You'd be adding your own arbitrary JavaScript as an attacker to do the things I mentioned before. Magecart style keyloggers, exfiltrate cookies, all this sort of thing. Now, there's an interesting thing about this. The only way I was able to get Chrome to do this is I had to turn something off. And if I go into the dev tools and we reload the page, and we get rid of the alert, we go back up here, into the response headers, I've got this. So your browser has a native XSS protection called the Xss Auditor. And what that auditor looks for is potential reflected cross-site scripting attacks. And if it sees it, it blocks it. I've turned it off. Many websites turn it off because it gets in the way of doing shitty things with your code. Because how many times have you seen a website passing really bizarre things in the query string? You know, pieces of JavaScript in the query string. They're called enterprise applications a lot of the time. They do this. So people turn it off because it gets in the way. Now, when you turn it off, you can do stuff like that. We're going to look at different levels, though, of turning it back on and some of the things we can do with it. And the first one is I'm going to go to here. This is the next tab. Identical website, a little bit like the Oxo example before. Identical website, I'm just changing a response header. So let's look at how the response header looks now. Okay, here, down to here. XSS protection 1. Remember it was 0 before. So let's have a look at what happens with 1. There's the script, search beer. That's it, no alert box. And if we look at the source code of the page and we go down here, we can see that alert beer in red. And if we hover over that, it's going to tell us that the token contains a reflected XSS vector. So this is now the browser's native XSS auditor saying, hang on a second, something has appeared in the URL that's also appeared in the source code, and it looks like XSS. So we're going to block it. Doesn't get to run. So this is cool, right? Like if someone tries to get that XSS vector to run, it's not going to work. If we go back here and look at the console, we'll also see it in there. Okay, XSS Auditor refused to execute a script because its source code was found within the request. So the request contained the code in the query string. It's come back, it's been seen in the response. Chrome has gone, this doesn't look very good. We probably shouldn't run that. Now, let's go on to another one. Let's have a look at what we've got in this example. So exactly the same page again, different header. And if we go down to here, 1, mode block. Now this is actually the default. So this is what you would get in Chrome by default if you didn't return any response header. So let's have a look at what happens this time. Paste in the script, run. Page doesn't work. Error, blocked by XSS Auditor. And the reason for this is that you don't want to have a situation where an attacker can pass something in the request and actually disable parts of the script on the page. Because what happens if I was an attacker and there was some JavaScript on the page and I thought I'm going to disable this JavaScript just simply by putting it in a query string? Because the XSS auditor would kill it. It says this string was in the request, it's then appeared in the response, we're going to take that little bit out. But maybe that little bit of JavaScript did some validation or had some other security protection or something. So what Chrome does by default is it says, this looks like XSS, bam, I'm killing the page, you get nothing. But how do you know about this? So, I mean, how do you guys as developers? So you're a developer, you've built a page that has this vulnerability in it. And people are going to this and all that's happening is the page is crashing. You want to know about it. Which brings us to the next one. So if we go over to here, let's have a look at what we've got set up this time. There. We've got a report attribute. And this looks a little bit like the CSP before, right? Remember the CSP where it's like when this gets violated, you can send a report somewhere? Same sort of deal here. I'm also reporting that off to report-uri.com. So let's see what happens this time. And to see this report, I'm going to need to open up Fiddler because I won't see it in the network tools of my browser. Bam, search. It's going to crash and fail. But if I go over to here, here's the request for the web page. Here is the report that gets submitted. Let's zoom in on that. So think about what this means. You can tell your browser the browser of your customers, that if there is an XSS vulnerability and the XSS Auditor fires, to send you a report to the address of your choosing, whether that be report URI itself as a service or your own reporting endpoint. And you will get this from the report. And this is cool, because look at the request URL. If you saw that request URL and you are the site owner of Search for Beer, you can go, oh, I think my search page has got a problem, because my search page is allowing untrusted user data to be reflected in the body. It is causing the XSS Auditor to fire. I know about this because I'm getting reports. So again, like, you're turning all of your users' browsers into beacons, which is super, super cool. Like CSP, it's also completely free. So it's kind of another one of these cases where there is security out there you can get for free. It's very, very simple, but it's very, very effective. Now, speaking about effective, there's some security out there which is not so effective. Brings us these guys. Anyone know who these guys are? The byline gives it away. Formerly Komodo. So I've spoken a little bit before at these events. In fact, I'm pretty sure I did it here last year as well, about extended validation. And it's kind of a funny time now. We were talking about this a little bit in the workshop yesterday, and we kind of got carried away with extended validation, where extended validation is, rather than just getting the padlock in your browser, you get the name of the entity. And organizations like Sectigo, formerly Komodo CA, formerly Komodo, they keep changing their name, I don't know why. So organizations like this desperately want to sell extended validation certificates because they can't sell domain validation certificates anymore because you get them for free. Who would pay for a domain validated certificate? It's pointless. Let's Encrypt will give you a free one. So they're trying to sell extended validation. And they try to sell it on reasons like this. The green address bar prominently displays your company name, provides you with a highly visual assurance to customers that your site is secure. What color is the address bar in Chrome? Is it green? Can anyone just confirm that quickly? All right, I'll give you a hint. No, it's not. It was green until a few months ago. Now it's not green. Different color. So if you tell people to look for the green address bar, and most importantly, if you tell them not to trust the site if it doesn't have a green address bar, and someone just like randomly happens to be using Chrome, which isn't really that many people, is it? Doesn't work. Does anyone know on Android or on iOS if the company name appears in the browser? It does not. We had this discussion yesterday. It doesn't. It's not there. So you're telling people to look for something that isn't there, and if it's not there, don't trust it, which kind of seems like self-defeating. They go on. This immediately gives them the confidence to complete their transaction. You've got to have confidence. Now, I'll give you a good example that has happened more recently that explains why this doesn't make any sense. Talk about PayPal. Now, I normally do this demo where I show like some of the world's top 1 million websites, and I point out that none of them have EV, but that a lot of financial services do have EV. A lot of banks have EV. Does everyone's going for their phones now. Does anyone know, does PayPal have EV? Who thinks it has EV? Who doesn't think it has EV? Interesting, interesting, interesting. Suspense. You know what's going to actually make this hard? I'm going to get rid of Fiddler. Otherwise, whoops, we'll go back to that later. Let's go to Fiddler, get rid of that, say okay to that, do that, close that. PayPal. Bam. Let's see if PayPal has EV. Okay, so PayPal has EV. Yes? No? You sure? You sure? Let's take the URL. Let's go to Firefox. It's going to want to update, isn't it? No, seriously, I practice all this. Okay, let's try it again. Okay, does PayPal have EV? But you just said it didn't. But now so it does. And you're looking really, really confused because you're like, what is this magic? How does this happen? So true story. We did NDC in Sydney around September. And I did the longer sort of EV talk, the one some of you might have seen before. And I sort of asked the question, does Facebook have EV? Who thinks eBay has EV? All this sort of stuff. And I'm like, let me show you what EV actually looks like. www.paypal.com. As you can see, this site has, oh shit. And it wasn't there. And I only realized while I was on the stage. And then I was like, wow, this is amazing. And Scott was there as well. And then I got off the stage and we're like trying to figure out what happens. And it looks like the way they've configured the cert and the way it's been installed in the Windows Trust Store, which is different to the way Mozilla manages their cert, which is all managed within Firefox, meant that you didn't get the EV indicator here. And we're like, oh, this is amazing, because this is sort of demonstrating the point that the site still works and people still trust it even when there's no EV. They're going to fix this really, really quickly, though. That was September. Still haven't fixed it. So isn't it interesting that you only actually see EV in Firefox? You don't see it in Chrome. Now, mind you, Google is testing removing EV altogether all the time anyway, because no one actually knows what it does. But you'd kind of think an organisation like PayPal, if they wanted to have EV, would have the resources to go and spend another few $100, would you not? But they don't care. So that's sort of interesting. And another thing that's very interesting is to look at the way the industry is representing sites using EV and why they should use it and what's actually happening. And let me show you what I mean by this. This is a video which Komodo, formerly, who knows, Sectigo, whoever the hell they are now, those guys created. Actually, it was Komodo at the time when they created this. It's a video that they're still using to try and promote the purchase of EV certificates. Let's have a look at it.
Visitors to a site with an EVSSL certificate see their browser address bar turn green whenever they are on a secure or HTTPS page, typically among the most critical during a session. Right at the moment of truth, when they're weighing whether or not to go forward with a transaction, this striking visual indicator, accompanied by information certifying their business name, location, and the certification authority that validated it, is presented, providing needed reassurance to continue.
Right at the moment of truth. Look for the green address bar, unless you're on PayPal, different thing. Did you see the website they use? They use one called Excalibur Cutlery. So Excalibur Cutlery is like the poster child for EV. This is Excalibur Cutlery. Ooh, that's embarrassing. I don't know, like maybe they just got sick of all the orders, right? And they're just, we don't need so much business. We'll back it off a little bit, go free. And I think I must have tweeted this, and someone got in touch with me and they said, hey, I just got this email. I just got a renewal email from Komodo, Sectiga, whoever. And in this renewal email, there's this, boost online sales with EVSSL. And there's a testimonial. This product really creates consumer confidence. My sales increased 20%. Who doesn't want 20% more sales? MostlyDead.com definitely wants 20% more sales, except for when they removed the certificate altogether and instead they went and got a free Let's Encrypt one. And they're still sending the emails saying, hey, Mostly Dead, 20% more sales. Nah, probably not. That's probably not what's happening. And we sort of come back to this situation again about the fact that EV is a positive visual indicator. And thinking that people are going to change their behavior based on the lack of a positive visual indicator like EV, whilst they've still got a padlock there, is crazy. So this is like it's like the veneer of security without any actual security in it whatsoever. And I was trying to find a way of kind of closing out the talk and giving you an image that represented the veneer of security with no security at all. And I found something that was kind of perfect. Anyone got one of these? No, of course you don't. Who would get one of these? This is a biometric lock. And the value proposition of the biometric lock is you don't need a key. So, you lock up your bike or something, you go out, you put your finger on it, unlocks. It has a screw on the side of it. And the screw does exactly what you're all thinking it does, right? Like it unlocks the whole padlock. And like that in and of itself is hilarious. But the best bit about this is the guy that found this, a guy called Lockpicking Lawyer. He goes around and basically pen tests physical locks. He submitted a report to the company that makes it. And the company gave it some very careful consideration. And they came back and said, this lock is invincible to people who do not have a screwdriver. And this is basically what EV is. All right, thanks very much, guys. I think we've got like 1 or 2 minutes if anyone has any questions. I did cut it a little bit fine. Oh, yes.
Do you actually get any useful insights by using the audits and dev tools?
Do you get any useful insight by using the audits and dev tools? In what way?
Any security insights in particular?
From things like Xss Auditor? Well, yeah, I mean, so the question is, do you get any useful insights from things like reports that come, you see?
From the audits tab in DevTools.
Oh, from the audits tab in DevTools. That's a good question for Scott. Do you get much useful info from audits tab? No? Okay, next question. Anyone else? All right, I think that pretty much takes us to time anyway. I'll be on again at the end of the day with Scott as well, and enjoy the rest of the day, guys.